Hello, Mr. Boothman here, and we are in Unit 6. Unit 6 is all about solving non-right triangles. Another word for non-right triangles is oblique triangles. And there are a couple of rules, a couple of formulas that we are going to mainly be using throughout this unit. So section 6.1 is the first of those two rules or formulas, and that is the law of sines. So let's talk about the law of sines. So again, before we've been learning methods to solve right triangles, but not all triangles are right. So we need to learn how to solve oblique triangles or non-right triangles. So here's an example of an oblique triangle. This is an acute oblique triangle where all of the angles are less than 90 degrees. There are also obtuse oblique triangles where one of the angles is greater than 90 degrees. In general, if we have an oblique triangle ABC like this, we call the angles the capital letters, capital A, B, and C, and then the side lengths are the lowercase a, b, and c. So that's usually how we differentiate between an angle and a side. And again, if I'm asking you to solve a triangle, I'm asking you to find every missing piece of information about the triangle. So I'm asking you to find every angle measure and every side length. To solve oblique triangles, we always need to know the measure of at least one side. And then any other two parts of the triangle. So two other sides, two angles, or another angle and a side. Now, uh, that means there are four total cases we could have. We could know two angles and one side. And throughout this unit, I'm going to use a lot of abbreviations for angles and sides. So an angle, obviously, I'll abbreviate with an A, side I'll abbreviate with an S. And this is just a way for us to keep track of what kind of information we've been given about the oblique triangle. So if I'm given two angles and a side length, then that is what we call an angle-angle side or angle-side-angle oblique triangle problem. That's what I was given. Or I could know two sides and an angle across from one of them. That's a side-side angle. Yes, we do put side first rather than after the A. I could know all three side lengths of the triangle. Or I could be given two sides and the included angle. That means the angle between them. So that would be a side angle side problem. Now notice I didn't include angle, angle, angle. And that's because, like we said right up here, I always have to know at least one side length. If I just know the three angles, I can't figure out anything about the side lengths of the triangle. So I need to know at least one side. So these four cases fall into two different rules or two different formulas that we can use to solve the respective triangles. So if I have an angle-angle side or angle-side-angle, or if I know a side-side and an angle opposite one of them, then I solve that using what we call the law of sines. And then if I know three side lengths, or if I know two sides and their included angle, I can use the law of cosines. So this section, section 6.1, is all about the law of sines. Section 6.2 is all about the law of cosines. So if ABC is a triangle with sides A, B, and C, then this right here is the law of sines. A over the sine of A equals B over the sine of B equals C over the sine of C. And that works for triangles that are acute or obtuse. Now, we derived the law of sines in class together. At the very first day, I introduced this unit. So if you want to see that again, or if you were gone that day, by all means, come talk to me about it. You don't really need to know where this comes from, but again, you all know my philosophy. I think it's incredibly important for you to understand where these things in math come from and why it is that we can use them. I think it helps you actually understand it more, which makes you more successful in math. So let's take a look at some examples of this. So the easiest example, using the law of sines, and again, that's just this set of ratios here, the law of sines. The easiest example of this is two angles and a side, so angle, angle, side, or angle, side, angle. Now, a lot of these problems, just about all of these problems, are going to hinge on this one simple fact that I'm sure we all remember from geometry. The angles of any triangle always add up to 180 degrees. It's going to be the crux of a lot of these solutions to these problems. So let's take a look at one of these problems. So I was given the measure of angles B and C, and then the length of side B, and they want me to find the remaining angles and sides. So I'm looking here at example number 1. One important thing to remember, and this shows up in certain questions, and this is also a way for us to check our answers and make sure that they make sense, is that the longest side of a triangle is always across from the largest angle measured. And then, on the other hand, the smallest or the shortest side is across from the smallest angle. So that's another great way for us to check our work and make sure that our answers actually make sense. Now, in general, there are a few steps to always solving these problems. First, if possible, draw a picture of this triangle. Draw a picture of this triangle using the information that you were given and figure out what kind of information you were given. So obviously we're looking at two angles in one side, so I know it's going to be angle, angle, side, or angle, side, angle. But in an actual problem, you're not going to know that this is angle, angle, side, or angle, side, angle. You need to look at this given information or draw a picture to be able to figure out, oh, this is angle, side, angle. That means I can use the law of sines to finish solving. So let's draw a picture first. So C is 102.3 degrees. So I'll call this angle C, 102.3 degrees, A and B. And then the sides across from each angle are, like that. They told me angle B is 28.7 degrees, and then side B is 27.4 feet long. So find the remaining angles and sides. That means I need to find A. I need to find side length A, and then side length C. Well, in this case, I was given an angle, and a side opposite one of the angles. So this is angle, angle, side. And they gave me two angles. So that means right away I can figure out the remaining angle, angle A. Remember that the angles of a triangle add up to 180 degrees. So the measure of angle A is going to be 180 degrees minus 102.3 plus 28.7, or angles B plus C. That's going to be 49 degrees. Use your calculator. So angle A is 49 degrees. And now I can use the law of sines to find side lengths A and C. So side length A over the sine of angle A equals side length B over the sine of angle B. Now, a lot of this unit, basically all of this unit, really depends on you being good at basic algebra. So how do I solve for angle A here? Well, I cross multiply. So A times the sine of 28.7 degrees equals 27.4 times the sine of 49 degrees. How do I get A by itself? Divide both sides by the sine of 28.7 degrees. Now, if you're like me, you don't need to do this intermediate step and you can jump straight to what A is. Good for you. Just make sure you're not making those mistakes. For the rest of you, it's totally fine if you need to do this intermediate step. So A is going to be 27.4 times the sine of 49 degrees all over the sine of 28.7 degrees. Use your calculator. We should be in degree mode. In fact, basically all of this unit should be in degree mode. We're talking about triangles, so rarely am I given a degree measure in terms of radians. Plug this all into a calculator, and I get A is about 43.06, and my unit was feet, so 43.06 feet. All right. And then I can solve for angle C very similarly, C over the sine of C, or 102.3 degrees, equals B over the sine of B. Now, notice I'm using the angle inside that I was given originally for both A and C, or to solve for both A and C. In this right here, I could have done A over the sine of A, but that was kind of an approximation. I just solved for the side length, so it's a little more proper to use the exact measures that I was already given. So if I solve for C just like I solved for A, then I'll have C equals 27.4 times the sine of 102.3 degrees all over the sine of 28.7 degrees. So C is about 55.75 feet. And that was the missing information. So now I know everything about this triangle. And again, we can check, is the longest side across from the largest angle? C is the largest angle, and C is the longest side. And then B is the smallest angle, and B is the shortest side. So everything does check out, makes sense. So that was an example of angle, angle, side. Going ahead and try example 2 on your own. It's very similar. And I'll go through example 3 right here. So, of course, word problems can show up from time to time. These do have applications in the real world. A pole tilts toward the sun at an 8-degree angle from the vertical. So instead of being straight up and down, forming a 90-degree angle, this pole is tilted 8 degrees from the vertical, and it casts a 22-foot shadow. So the shadow is 22 feet. This is 8 degrees from the vertical, so 90 plus 8, that's a 98-degree angle. And then it says the angle of elevation from the tip of the shadow, right here, to the top of the pole is 43 degrees. Angle of elevation, this is from last unit. See, these things don't go away. I'm looking straight ahead, and then elevation means I'm going up 43 degrees. So this angle right here is 43 degrees. And I want to know how tall this pole is. So I want to know this side length, the height. So again, we started by drawing a picture. Let's identify the information we were given. I have an angle, I have a side length, and I have another angle. So angle, side angle in this case. How tall is the pole? Well, I have h over the sine of the angle opposite that, sine of 43 degrees, equals, I have 22, over, I need the sine of that third angle. So, we use the fact that all of the angles add up to 180 degrees. So this angle in here is 180 minus 98 degrees plus 43 degrees. In other words, that angle is 39 degrees, so the sine of 39 degrees. Cross multiply, divide, so h equals 22 times the sine of 43 degrees over the sine of 39 degrees. Plug it all into our calculator, and we will get that the height is about 23.84 feet. And that's it. So the law of sines itself is pretty simple. It's just a ratio. A lot of this unit I don't think is particularly difficult, but it does require you to understand what the problem is asking. So you need to be able to set up the picture and to recognize the information you were given, and then to do that basic algebra to solve here for what you're actually looking for. So not too difficult, I don't think, but by all means, practice, practice, practice. And then we do get to this next part that is a little more challenging, of course. And that is what we call the ambiguous case. So we had these 4 cases up here. 2 angles in any side, angle, angle, side, or angle, side, angle. We just looked at examples of those. Those don't get too much more challenging than that. We could also have 2 sides and an angle opposite one of them. and that is what we call the ambiguous case. So side, side, angle. So let's consider a triangle where we know two side lengths and an angle opposite one of them. So again, from our derivation of the law of sines, we know that the height of the triangle, that h right here, is b times the sine of a. So if you want to see what I mean by that, let's call that a, b, c, and then that's c, a, and b. This is the height, and that height right here is going to be the sine of a equals opposite, I'm looking at this triangle right here, over hypotenuse, or h equals b times the sine of a. So that's where that formula is coming from. Now let's consider a triangle where we know a, b, and a, or two side lengths and an angle opposite one of them. There are a bunch of different cases there are a bunch of different possible triangles that could be the triangle represented by this information. So if I'm just given this information, there's a lot of different possibilities of the triangle that I could be looking at. So if angle A, the angle I'm given, is an acute angle, there's a bunch of different possibilities. If side length A is less than the height, then there's no possible triangle. And so there's a lot of cases here. You don't need to memorize this. This is all at the bottom of your district reference formula sheet, so don't worry about that too much. But do understand what this means and why we're looking at this. This is called the ambiguous case for a reason, because there's always possibilities of the triangle given this information. So if A is less than H and angle A is acute, then just looking at this picture here, there's no possible way to form a triangle. None. If angle A is acute and A equals the height, then there's one possible triangle. It's a right triangle right here. If angle A is acute and A is greater than side length B, then there's one possible triangle right here. And here's the trickiest part, this next example. If angle A is acute and H is less than A is less than B, then there are two possible triangles. Just looking at this here, if A is less than B but is greater than H, then I could have side length here, or I could swing that side length out here and have this triangle. So there's two possible triangles in that case, and we're going to talk about how to solve in that case. We could also have angle A being obtuse. If angle A is obtuse and either of these two things is true, A is less than B or A equals B, then there's no possible triangle. That's just looking at the picture here. There's no way to finish that triangle. If angle A is obtuse and A is greater than B, then there's one possible triangle. So again, there's nothing there that you need to memorize. There is, however, that case where I could have two possible triangles. So we're going to go through these three examples, and I want us to use the information that we're given, kind of check these cases to tell us how many solutions we're going to have, and then we'll solve it just like we had solved the first few examples in this section, using the law of sines. If we have a triangle that is not possible, so using the information we're given, if we get one of those cases where there's no possible triangle, even if you don't catch that before you start using your calculator, it's going to stop you. It's going to say there's no solution. It's that case where we could have two possible triangles that we need to watch out for, because your calculator won't tell you that. So we're going to talk about that once we get to it. But for now, let's look at example number 4. So I'm given A, B, and angle A. I need to find the remaining angles and sides if possible. So first thing I'm going to do, I'm going to check to see, and this should always be your first step, I'm going to check to see if H is less than A is less than B. Because if it is, then I know I have that special case where there's two possible triangles, and I'm going to need to solve each of those two triangles. If not, then I can just figure out which other case I'm looking at and then solve it like normal. So H equals B times the sine of A, or 12 times the sine of 42 degrees. Plug that into a calculator. B is about 8.03. Is 8.03 less than 22 less than 12? Well, obviously not. 22 is not less than 12. So I know in this case that I do not have two triangles. Angle A is acute, and A is greater than B, so this is an acute angle, and A is greater than B. So looking at my cases here, I see right here, there's one possible triangle, so one solution. So that's good news for me. That means there's a little less work I have to worry about. Let's try drawing this triangle. So A, B, C. Angle A is 42 degrees. Side length A is 22. Side length B is 12. So in this case, let's see. I need to find at least one more angle using the law of sines before I can just do my adding up to 180 degrees. So I have 22 over the sine of 42 degrees equals 12 over the sine of angle B. So solve for angle B. The sine of B equals 12 times the sine of 42 degrees divided by 22. Now, here's where we need to pull in all of our knowledge from Unit 5, all of our knowledge about trig. I can plug this whole thing into my calculator, and that is going to be what the sine of angle B equals. So if I need to solve for angle B, then I need the inverse sine. So to find what B equals, I'm going to take the inverse sine of this. The inverse sine of whatever this ends up being. And so I'll get, and you know, that's the second function of the sine button on your calculator. So I get that angle B is about 21.41 degrees. And so now that I know that angle C is going to be 180 degrees minus angles A plus B. So angle C is about 116.59 degrees. And I'm rounding everything to two decimal places, to general rule of thumb that we do in math. So angle B is 21.41 degrees. Angle C is 116.59 degrees. And then I still need to solve for side length C. Side length C, I'm kind of out of room here, so I'm going to erase some of my work. Side length C over the sine of angle C, so 116.59 degrees, equals, we'll do A over the sine of A. So C equals 22 times the sine of 116.59 degrees over the sine of 42 degrees. Plug all of that into our calculator and we get that C is about 29.40 inches, because that's the unit that I was given. So C is about 29.40 inches. And that's all the missing information for this triangle. So this works very much the same way. I will need to use the inverse sine function to solve for an angle measure, but that's okay. Again, nothing too complicated about that. It's really just figuring out which case I have, how many solutions I'm going to have. Excuse me. So let's look at example number 5. And often for these kinds of problems, this side-side angle, it is good to tell how many solutions that we have. So in this case, we had one solution. Example number 5, let's take a look here. Let's check h is less than a is less than b. So h is equals b times the sine of 85 degrees. Plug that into a calculator and we get h is about 24.90. Okay, so 24.90 less than 15 less than 25. Well, I can tell right away that that's not going to work. So let's narrow down our other choices. A, 85 degrees. That is an acute angle. And A is less than H. And so I look up here, there's no solution. So I can stop right away. There's no other angles or sides to solve for. This is not a possible triangle. And why? Because we look at this picture. If A is less than H, there's no way that I can meet that line down there. There's no possible way for me to finish that triangle. Now, if you hadn't checked that, and you went and tried to finish solving this in your calculator, and you did, all right, A over the sine of A equals B over the sine of B, and then you tried to solve for B, then the sine of B equals 25 times the sine of 85 degrees, all over 15. And then you did the inverse sine of whatever this ends up being. Your calculator would stop you and say, error. So this does not exist. That's because this value right here ends up being greater than 1. And we know that the domain of the inverse sine function is between -1 and 1. So your calculator is going to stop you. It's going to say there's no possible angle measure for this. So in that case, that's great. So even if you missed this fact right here, you still would get the right answer. But you need to be able to recognize that when your calculator says there's an error, it's because there's no solution. Now let's take a look at this last example, example number 6. We saw one example with one solution, one example with no solutions. So this example I'm going to say probably has 2 solutions, just to give you the full range of the possibilities. But let's check. So we check H, is that less than A, which is less than B? So H equals B times the sine of angle A. Plug that into a calculator, I get about 10.86. Is 10.86 less than 12, less than 31? Yes. So what that means is that there are 2 solutions, 2 possible triangles. That that side A will be swings in either direction. It could either be here or it could be here. In other words, angle B, right here or here, is either acute or obtuse. So let's check 2 solutions. So I need to solve for angle B, angle C, and side length C. Let's consider where B is acute first. So this is 31, this is 12, this is side length C, this is 20.5 degrees. And let's set up some of our, or one of our law of sines ratios. So 12 over the sine of 20.5 degrees equals 31 over the sine of B. So the sine of B equals 31 times the sine of 20.5 degrees over 12. You take the inverse sine and we'll get B is about 64.78 degrees. So that's the angle measure for B that my calculator gives me. From there, sorry, I can solve for angle C. C is 180 degrees minus A plus B, which is about 30, oh, I'm sorry, not 30. Which is about 94.72 degrees. And then from there, I can set up my ratio to solve for side length C equals, let's do A over the sine of A. So C equals 12 times the sine of 94.72 degrees over the sine of 20.5 degrees. Plug that into a calculator, and you get 34.15 meters. So that's the unit they gave me. So 34.15 meters. Sorry, I'm getting a little cramped here for my spacing. So that's one possible triangle, and I apologize, now I'm looking at the time of this video, it's been a little long. I am sorry, we will be going through this in class this whole week. Just watch the parts of this video that you need, of course, as always. But I know I had two solutions to this problem. I had two solutions because h was less than a, which was less than b. So there are two possible triangles that could be set up from this problem. This was one of them, where angle b is acute. Now I also have a triangle possibility where angle b is obtuse. And that's because this side length a here could either be here, or it could swing back to the other side like this. So a is still 20.5 degrees, side length a is still 12, side length b is still 31, but I need an obtuse angle for b, right here. Now I could set up my ratio just like I did over here, but we already solved that. Our calculator gave us an answer of 64.78 degrees for b. Well, that's obviously not obtuse. How do I find this other angle measure for b? Well, luckily, it's pretty easy. All we do is we say this other possible solution for b is going to be 180 degrees minus whatever I got from my calculator, 64.78 degrees, which is 115.22 degrees. So that's 115 point... It's not going to let me write past that line there. So B equals 115.22 degrees. Now that means C is going to be 180 degrees minus A plus B, which is, let's see here, 44.28 degrees. And then side length C, it's going to be C over the sine of 44.28 degrees equals 12 over the sine of 20.5 degrees. So C is 12 sine of 44.28 degrees over the sine of 20.5 degrees. Plug that into a calculator and we get 23.92 meters. Two possible solutions given this information. There were two possible triangles. Now, why does this work? Why can I just subtract the answer my calculator gave me from 180? That has to do with the sine. So we took the inverse sine to find b right here. We talked about how when we were graphing the inverse sine function, or when we were graphing all of the inverse trig functions last unit, that we had to restrict the domain to make it one-to-one, to be able to graph it, to be able to ask questions about it. But we knew that there were still two possible angles that we got. So like the sine of 1/2, or two different angles give me a sine equal to 1/2, right? There's 30 degrees and then there's one at 150 degrees. Well, it turns out that that is always true, and they're always going to be supplementary angles. So that's why I can just subtract it from 180 to get the other possible angle measure, and then use that to finish solving the triangle. We'll talk about that a lot more in class, and I'll find other ways to explain that too, because I'm kind of rushing now because I know this is a long video. So that's about it for the law of sines. Again, the law of sines itself is pretty easy. The math itself is pretty easy. It's just setting up our problems. So if we're given two angles and a side opposite one of them, then pretty straightforward, not too hard, I don't think. If we're given two sides and an angle, the ambiguous case, um, then it's still not too difficult. We just always need to check for this right here. Are there two possible triangles? Okay, so rewatch parts of this that confused you, write down your questions, please bring them to class, bring them to me in tutoring. Try that problem up here that I asked you to, and have a great day. Thank you so much.